In 2018, Gretel earned $32,000. She paid tax of 24% on these earnings. Work out the amount she paid in tax in 2018. The amount Gretel paid in tax will be equal to 24 over 100 times $32,000. This gives us $7,680. In 2019, Gretel's earnings increased by 7%. Work out her earnings in 2019. Her total earnings in 2019 will be equal to $32,000 plus 7% of $32,000, and so that is equal to $34,240. Gretel invests $5,000 at a rate of 2% per year compound interest. Calculate the value of her investment at the end of 3 years. In this case, we are going to use the compound interest formula. The big A represents the value of Gretel's investment at the end of 3 years, which we are finding. Small a represents the initial amount Gretel invests, which has been given as $5,000. R is the rate, which is 2. T is the time duration in years for which the money is invested, and that has been given as 3. So when we type this into the calculator, we have $5,306.04 correct to 2 decimal places. 1 month, Gretel spent a total of $360 on presents. She spent 1/5 of this total on presents for her parents. She spent 2/3 of the remaining money on presents for her friends. She spent the rest of the money on presents for her sisters. Calculate the percentage of the $360 that she spent on presents for her sisters. To be able to find the percentage, we first of all need to find the amount of money Gretel spent on presents for her sisters. We've been told that Gretel spent 1/5 of the total, which is $360 on presents for her parents. And so to find this amount, that will be equal to 1/5 times $360, and this is equal to $72. We were also told that she spent 2/3 of the remaining money. The key word here is the remaining money. And so to find the amount of money she spent on presents for her friends, that will be 2/3 of the remaining money, which is $360 minus $72, and that is equal to $192. In addition, we've also been told that she spent the rest of the money on presents for her sisters. And so to find what this amount is, we subtract the sum of $72 and $192 from $360. That gives us $96. And so the percentage of the $360 she spent on presents for her sisters will be $96 divided by $360 times 100%. This gives us 26.7%. Arjun earned $36,515 in 2019. This was an increase of 9% on his earnings in 2018. Work out his earnings in 2018. Let's represent his earnings in 2018 with X, and let's represent his earnings in 2019 with Y. And so from the information given in the question, we know that Y is equal to X plus 9% of X. 9/100 is the same as 0.09. We want to find his earnings in 2018, and so let's make X the subject. When we make X the subject, we have X is equal to Y over 1.09. We've been given Y in the question as $36,515. And so when we substitute this into the equation, we now have X is equal to $33,500. Arjun and Gretel each pay rent. In 2018, the ratio of the amount each paid in rent was Arjun is to Gretel is equal to 5:7. In 2019, the ratio of the amount each paid in rent was Arjun is to Gretel equals 9:13. Arjun paid the same amount of rent in both 2018 and 2019. Gretel paid $290 more rent in 2019 than she did in 2018. Work out the amount Arjun paid in rent in 2019. So first, let's set up our ratios. In 2018, we have the ratio as 5:7. Let's represent the actual amount Arjun paid in rent in 2018 with X, and let's represent the actual amount Gretel paid in rent in 2018 as Y. In 2019, we have the ratio as 9:13. We were told that Arjun paid the same amount of rent in both 2018 and 2019. And so if we have X in 2018, we are also going to have X in 2019. For Gretel, she paid $290 more rent in 2019 than she did in 2018. So if we have Y in 2018, we are going to have Y plus 290 in 2019. So for our first ratio, the equation we get will be X over 5 is equal to Y over 7. And when we make Y the subject from this equation, we get Y is equal to 7 over 5x. For our second ratio, when we set up our equation, we have Y plus 290 over 13 is equal to X over 9. And when we make Y plus 290 the subject, we have Y plus 290 is equal to 13 over 9x. When we make Y the subject, we have 13 over 9x minus 290. So we now have two equations to solve. When we put the second equation in the first equation, we have 13 over 9x minus 290 is equal to 7 over 5x. When we group like terms, we have 13 over 9x minus 7 over 5x is equal to 290. 13 over 9x minus 7 over 5x is 2 over 45x. And when we make x the subject, we have 290 times 45 divided by 2, which is equal to 6,525. The heights, H meters of the 120 boys in an athletics club are recorded. The table shows information about the heights of the boys. Write down the modal class. The modal class is the class with the highest frequency. The highest frequency is 30, and the class with this frequency is H is greater than 1.5 and lesser and equal to 1.6. Calculate an estimate of the mean height. The mean is equal to sigma f of x divided by sigma f. In this case, sigma f of x represents the total sum of the heights of all the 120 boys, and sigma f represents the total number of boys. And so to find sigma f of x, we first need to find an average of the heights. So for the first range of heights, the average height is going to be 1.3 plus 1.4 divided by 2, giving us 1.35. 1.4 plus 1.5 divided by 2 gives us 1.45. 1.5 plus 1.6 divided by 2 gives us 1.55. 1.6 plus 1.7 divided by 2 gives us 1.65. 1.7 plus 1.8 divided by 2 gives us 1.75. 1.8 plus 1.9 divided by 2 is 1.85. And so, sigma f of x will now be equal to 7 times 1.35 plus 18 times 1.45 plus 30 times 1.55 plus 24 times 1.65 plus 27 times 1.75 plus 14 times 1.85 divided by 120. When we type this into the calculator, we get 1.62. Correct to 3 significant figures. One boy is chosen at random from the club. Find the probability that this boy has a height greater than 1.8 meters. The probability that the chosen boy has a height greater than 1.8 is equal to the number of boys with a height greater than 1.8 meters divided by the total number of boys. And so this gives us 14 over 120, which can further be simplified to 7 over 60. 3 boys are chosen at random from the club. Calculate the probability that one of the boys has a height greater than 1.8 meters and the other 2 boys each have a height of 1.4 meters or less. The probability that the first boy picked has a height greater than 1.8 meters is 14 over 120. After the first boy is picked, the number of boys reduced to 119, and so the probability that the second boy picked has a height of 1.4 meters or less is 7 over 119. After the second boy is picked, the probability that the third boy has a height of 1.4 meters or less is 6 over 118. There are 3 different variations for the orders in which these boys are picked, and so we can lay the probability down like this or multiply one probability by 3, and when we type this into the calculator we have 0.00105 correct to 3 significant figures. Use the frequency table on page 4 to complete the cumulative frequency table. For age is less than and equal to 1.6, we have 7 plus 18 plus 30 being equal to 55. For age is less than and equal to 1.7, we have 7 plus 18 plus 30 plus 24 giving us 79. For age is less than and equal to 1.8, we have 7 plus 18 plus 30 plus 24 plus 27 giving us 106. For age is less than and equal to 1.9, we have 7 plus 18 plus 30 plus 24 plus 27 plus 14 giving us 120. On the grid, draw a cumulative frequency diagram to show this information. So on the grid, we are going to plot the points 1.47, 1.525, 1.655, 1.779, 1.8 106, 1.9 120. When we are done, we draw a smooth line starting from the origin and connecting all the points. Use your diagram to find an estimate for the median height. Half of 120 is 60, and so when we map 60 on the diagram, we have the median height as 1.62 meters. Use your diagram to find an estimate for the 40th percentile. 40% of 120 is 48. And when we map 48 on the diagram, we get the 40th percentile to be 1.58 meters. S is equal to UT plus half AT squared. Find the value of S when U is equal to 5.2, T is equal to 7, and A is equal to 1.6. All we need to do is to substitute the numbers given for the letters into the equation. And so that gives us S is equal to 5.2 times 7 plus half times 1.6 times 7 squared. When we type this into the calculator, we get S equals 75.6. Simplify 3a minus 5b minus a plus 2b. When we group like terms, 3a minus a gives us 2a, and minus 5b plus 2b is minus 3b. And so our final answer here is 2a minus 3b. Simplify 5 over 3x times 9x over 20. X cancels out in the numerator and the denominator. 5 goes into itself once and goes into 24 times. 3 goes into itself once and goes into 9 3 times. And so for the numerator, we have 1 times 3 giving us 3. And for the denominator, we have 1 times 4 giving us 4. And so our final answer is 3 over 4. Solve 15 over x is equal to negative 3. X divides on one side of the equation, and so when it moves to the other side, it goes to multiply negative 3. When we make x the subject, we have 15 divided by negative 3, which is equal to negative 5. Solve 4 times 5 minus 3x is equal to 23. When we expand the brackets, 4 times 5 is 20. 4 times negative 3x is negative 12x. When we group like terms, we have 12x is equal to 20 minus 23. 20 minus 23 is negative 3. When we make x the subject, we have x equals negative 3 divided by 12. This can further be simplified to give us x is equal to negative 1 over 4 or negative 0.25. Simplify 27x raised to the power 9 or raised to the power 2 over 3. 27 can be rewritten as 3 cubed. By the laws of indices, we can rewrite this as 3 cubed raised to the power 2 over 3 times x raised to the power 9 or raised to the power 2 over 3. When the powers of 3 multiply, we get 3 times 2 over 3 equals 2. 3 raised to the power 2 is 9. For the powers of x, 9 times 2 over 3 gives us 6. And so our final answer is 9x raised to the power 6. Expand and simplify. 3x minus 5y times 2x plus y. When we expand the brackets, 3x times 2x is 6x squared. 3x times y is 3xy. Negative 5y times 2x is negative 10xy. Negative 5y times y is negative 5y squared. 3xy minus 10xy is negative 7xy. So our final answer becomes 6x squared minus 7xy minus 5y squared. Draw the image of triangle T after a reflection in the line y is equal to negative 1. So first, we need to draw the line of reflection. And so that will be a horizontal line passing through negative 1 on the y-axis. Since we move point C 2 units downwards to touch the line of reflection, we also need to move 2 units downwards from the line of reflection to pin the new position of point C. After repeating the same process for all the vertices of triangle T, we are able to map out the reflected image of triangle T. Draw the image of triangle T after a rotation through 90 degrees clockwise about 0, 0, which is the origin. You can choose to use tracing paper for part B, or you can choose to go this route as well. Let's mark the center of rotation. So first, let's draw a line from point A to the origin. Then, using a set square or a protractor, we are going to measure 90 degrees in the clockwise direction from the line we've just drawn and mark this position. Now we are going to draw a straight line from the origin passing through the 90 degrees mark. The new position of point A should be anywhere along this line such that the distance from the origin to the new position of point A is equal to the distance from the origin to the initial position of point A. We are going to repeat this process to pin the new positions of points B and C. When we are done, we are able to map out the rotated image of shape T. Describe fully the single transformation that maps triangle T onto triangle A. When we look at both triangles T and A, we can tell straight away that this is a translation because shape A looks exactly like shape T, only that it is in a different location. So now we need to find the translation vector, and from the illustration on the diagram, this vector is 5, -6. And so, the full description for this transformation will be translation by the vector 5, negative 6. X is an integer. The universal set E is equal to X such that X is greater than and equal to 41 and less than and equal to 50. Set A is equal to X such that X is an odd number. Set B is equal to X such that X is a multiple of 3. Set C is equal to X such that X is a prime number. Complete the Venn diagram to show this information. So first, we need to list the elements of all the sets. There are no elements common to sets A, B, and C. There are also no elements common to sets B and C. The element common to A and B is 45. The elements common to set A and C are 41, 43, and 47. The element in set A only is 49. The elements in set B only are 42 and 48. The elements in the universal set that are neither in set A, B, or C are 44, 46, and 50. List the elements of A intersection C. A intersection C are the elements that are common to set A and set C. And from the Venn diagram, these elements are 41, 43, and 47. List the elements of B union C complement. The elements in B union C complement are the elements that are neither in set B or in set C, and these are 44, 46, 49, and 50. Find the number of elements that are in A and B and C. From the Venn diagram, there are no elements in this region, and so our answer here is 0. Rahim makes baskets and mats. Each week, he makes X baskets and Y mats. He makes fewer than 10 mats. The number of mats he makes is greater than or equal to the number of baskets he makes. One of the inequalities that shows this information is y is less than 10. Write down the other inequality. The description for the other inequality is the number of mats he makes, which is y, is greater than or equal to the number of baskets he makes, which is x. And so we have y is greater than and equal to x. He takes 2 1/4 hours to make a basket and 1 1/2 hours to make a mat. Each week, he works for a maximum of 22.5 hours. Show that 3x plus 2y is less than and equal to 30. If Rahim works a maximum of 22.5 hours each week, then it means that the total number of hours he spends making baskets and mats, which is 2 1/4 times x plus 1 1/2 times y, is less than and equal to 22.5. In the next step, we convert the mixed fractions into improper fractions. For 2 1/4, we have 4 times 2 plus 1, which is 9, divided by 4. For 1 1/2, we have 2 times 1 plus 1, which is 3, divided by 2. In the next step, we multiply through by 4. 4 times 9/x is 9x. 4 times 3/2y is 6y. 4 times 22.5 is 90. When we divide through by the common factor of the terms, which is 3, we have 9x divided by 3, which is 3x. 6y divided by 3 is 2y. 90 divided by 3 is 30. On the grid, draw 3 straight lines and shade the unwanted regions to show these inequalities. We have 3 inequalities in total. For the inequality y is less than 10, we need to draw the straight line y is equal to 10. For the inequality y is greater than and equal to x, we need to draw the line y is equal to x. For the inequality 3x plus 2y is less than and equal to 30, we need to draw the line 3x plus 2y is equal to 30. Note that since the line y is less than 10 does not include an equal sign, this line will be drawn as a dotted line. For the inequality y is less than 10, the region below y is equal to 10 is wanted, and so we are going to shade the region above y is equal to 10. For the inequality y is greater than and equal to x, the line above y is equal to x is wanted, and so we are going to shade the region below y is equal to x. For the inequality 3x plus 2y is less than and equal to 30, the region below the line is wanted, and so we are going to shade the region above the line. He makes $40 profit on each basket he sells and $28 profit on each mat he sells. Calculate the maximum profit he can make each week. So to be able to determine this, we first need to mark the vertices of our wanted region. We cannot mark and pick these points because y is equal to 10 is a broken line and does not constitute the boundaries for the wanted region. And so we are going to come one step below and pick these points. So for our vertices, we have 0, 0, 0, 9, 6, 6, 4, 9. For Rahim's profit equation, we have 40 times x plus 28 times y. When we put in the coordinates into the profit equation, these are the values we get. And from this, the maximum profit is $412. The diagram shows the positions of 3 points A, B, and C in a field. Show that BC is equal to 118.1 meters, correct to 1 decimal place. To find the length of BC, we can apply the cosine rule. This gives us BC squared is equal to AB squared plus AC squared minus 2 times AB times AC times cosine of angle BAC. AB is 80 meters. AC is 115 meters. Angle BAC is 72 degrees. When we slot in these values into our equation and make BC the subject, we have square root of 80 squared plus 115 squared minus 2 times 80 times 115 times cosine of 72 degrees. When we type this into the calculator, we get 118.0639 meters. The first number after the decimal point is 0. The number after 0 is greater than 5, and so we add 1 to 0 and ignore the rest of the numbers. So BC is equal to 118.1 meters, correct to 1 decimal place. Calculate angle ABC. To find angle ABC, we can apply the sine rule. This gives us sine of angle ABC divided by AC is equal to sine of angle BAC divided by BC. When we make angle ABC the subject, we have sine inverse of sine of angle BAC divided by BC times AC. Angle BAC is 72 degrees, BC is 118.1 and AC is 115. When we type this into the calculator, we get angle ABC equals 67.8 degrees, correct to 1 decimal place. The bearing of C from A is 147 degrees. Find the bearing of A from B. In the illustration, we have indicated the bearing of C from A with a green arrow, and we've indicated the bearing of A from B with a red arrow. We've labeled this as X. X plus B is equal to 360 degrees. A and B are interior angles, and so this means that A plus B is equal to 180 degrees. We can find A by subtracting 72 degrees from 147 degrees. This gives us B equals 105 degrees. So now that we found the value of B, we have X plus 105 degrees equals 360 degrees. This gives us X equals 255 degrees. Find the bearing of B from C. On the diagram, we've labeled the bearing of B from C with a red arrow and labeled it as Y. Y is equal to U minus W. So to find Y, we need to find the values of U and W. We found angle ABC as 67.8 degrees. U is one of the angles in the triangle ABC, and so when we subtract the sum of 67.8 degrees and 72 degrees from 180 degrees, we get U is equal to 40.2 degrees. W and 147 degrees are interior angles, and so this means that W plus 147 degrees is equal to 180 degrees. This gives us W is equal to 33 degrees. When we put these values into the equation for Y, we have Y equals 40.2 degrees minus 33 degrees. This gives us Y equals 7.2 degrees. Mitchell takes 35 seconds to run from A to C. Calculate his average running speed in kilometers per hour. We know the average speed formula is the total distance traveled divided by the time duration. The distance from A to C is 115 meters, and it took Mitchell 35 seconds to run from A to C. So we have 115 meters divided by 35 seconds. To convert 115 meters to kilometers, we divide by 10 cubed. And to convert 35 seconds to hours, we have 35 divided by 3,600 hours. When we type this into the calculator, we get 11.8 kilometers per hour, correct to 3 significant figures. Calculate the shortest distance from point B to AC. The shortest distance is from point B to a point on AC such that the line is perpendicular to AC. We've labeled this as X. To find X, we can apply SOHCAHTOA. This gives us sine 72 degrees is equal to X divided by 80 meters. When we make X the subject, we have 80 times sine 72 degrees. When we type this into the calculator, we get 76.1 meters, correct to 3 significant figures. On the axis, sketch the graph of y is equal to sine x for x is greater than and equal to 0 degrees and less than and equal to 360 degrees. This is pretty straightforward. You can recall this from memory, or you can try to map out the main points of the curve. Then you connect the points with a smooth line. When x equals 0, y is equal to sine 0 and sine 0 is 0. When x is 90, y is equal to sine 90 is 1. When x is 180 degrees, y is equal to sine 180 degrees and sine 180 degrees is 0. When x is equal to 270 degrees, y is equal to sine 270 degrees and this is negative 1. When x is equal to 360 degrees, y is equal to sine 360 degrees and this is 0. So after plotting these points, you can connect them with a smooth line. Describe fully the symmetry of the graph. Y is equal to sine x for x is greater than and equal to 0 degrees and less than and equal to 360 degrees. At the point 180 degrees 0, when we rotate this shape 180 degrees, we have it looking exactly like the original, and when we rotate it another 180 degrees, we come back to the original, and so we have rotational symmetry of order 2 about the point 180 degrees 0. Solve for sine x minus 1 equals 2 for x is greater than and equal to 0 degrees and less than and equal to 360 degrees. When we make sine x the subject, we have 2 plus 1, which is 3, divided by 4. To be able to find the full range of values for x, we need to first find the value of alpha, which is sine inverse of 3 over 4. When we type this into the calculator, we get alpha equals 48.6 degrees, correct to 1 decimal place. So now we need to draw our quadrants. Since sine x is equal to 3 over 4 and 3 over 4 is a positive value, then it means that we draw our lines in where sine is positive. The angle from the base to the line is alpha. And so when we go around this quadrant, the first value of x is 48.6 degrees. When we go around the quadrant the second time, this angle becomes 180 degrees minus 48.6 degrees, giving us 131.4 degrees. And so our final values for x are x equals 48.6 degrees and x equals 131.4 degrees. Write x squared plus 10x plus 14 in the form x plus a squared plus b. In the first step, we add and subtract the square of a number, which we get by dividing the coefficient of the x term, which is 10, by 2. This part of the expression becomes x squared plus 10x plus 5 squared, and this part of the expression becomes negative 11. X squared plus 10x plus 5 squared can be written as x plus 5 squared. This gives us our final answer as x plus 5 squared minus 11. On the axis, sketch the graph of y is equal to x squared plus 10x plus 14, indicating the coordinates of the turning point. So first, since we are dealing with a quadratic function, we know that its graph is going to be in the shape of a parabola. The second thing is that since the coefficient of the x squared term is positive, then it means that the turning point is going to be a minimum. In the previous question, we transformed x squared plus 10x plus 14 into x plus 5 squared minus 11. In this form, it is easy to determine the coordinates of the turning point. To find the x coordinate of the turning point, we equate x plus 5 to 0, and this gives us negative 5. The y coordinate is negative 11. The diagram shows a sector of a circle with center O, radius 8 cm and sector angle 165 degrees. Calculate the total perimeter of the sector. So the total perimeter of the sector is equal to BO plus OA plus the arc AB. BO is 8 cm, OA is 8 cm. Arc AB is 165 degrees divided by 360 degrees times 2 pi times 8. When we type this into the calculator, we get 39.0 centimeters, correct to 3 significant figures. The surface area of a sphere is the same as the area of the sector. Calculate the radius of the sphere. The surface area A of a sphere with radius r is A is equal to 4 pi r squared. So we've been told that the surface area of a sphere is the same as or is equal to the area of the sector above. Let's represent the radius of the sphere as rs and the radius of the sector as r. And so the area of the sphere is 4 pi times rs squared, and the area of the sector is theta over 360 degrees times pi r squared. Since we are interested in finding the radius of the sphere, which we have represented as rs, we have to make it the subject of the equation. This gives us square root of 1 over 4 times theta over 360 degrees times pi r squared. We already know the value of theta, which is 165 degrees, and we know the radius of the sector is 8. And so when we type this into the calculator, we get 2.71 centimeters, correct to 3 significant figures. A cone is made from the sector by joining OA to OB. Calculate the radius r of the cone. From the information we've been given in the question, we can say that if the cone is made from the sector by joining OA to OB, then it means that the arc AB of the sector is the same as the base circle of the cone. And so we can find the arc of AB by 165 degrees divided by 360 degrees times 2 pi times 8. And the base of the cone, which is a circle, is 2 pi r. When we make r the subject, we have 3.67 centimeters, correct to 3 significant figures. Calculate the volume of the cone. The volume V of a cone with radius r and height h is V equals 1 over 3 pi r squared h. To find the volume of the cone, all we need to do is to find the values of r and h and substitute these values into the formula. We've already found the value of r in the previous question. This is 3.67. To find the height of the cone, we can apply Pythagoras theorem. And so this gives us OA squared is equal to h squared plus r squared. When we make h the subject, we have square root of OA squared minus r squared. Remember that OA is the same as the radius of the sector, and that is 8 centimeters. Now that we have all these values, the volume of the cone is 1 over 3 pi times 3.67 squared times square root of 8 squared minus 3.67 squared centimeters cubed. When we type this into the calculator, we get 100 cm cubed, correct to 3 significant figures. A rhombus ABCD has a diagonal AC where A is the point -310 and C is the point 4, -4. Calculate the length AC. By applying the distance formula, we have AC equals square root of -3 minus 4 squared plus 10 minus -4 squared. This gives us 15.7. Show that the equation of the line AC is y is equal to -2x plus 4. The equation of any line can be written in the form y is equal to mx plus c. So now all we need to do is to find the values of m and c. M is the gradient, and that is equal to 10 minus -4 divided by -3 minus 4. This gives us -2. So now we have y equals -2x plus c. To find the value of c, we can use one set of coordinates on the line AC. If we pick the coordinates of point A, we have 10 is equal to -2 times -3 plus c. When we make c the subject, we have c equals 4. Hence, the equation of the line AC is y is equal to -2x plus 4. Find the equation of the line BD. Let's try to visualize the situation. We know that AC is a diagonal in a rhombus ABCD. And so if this is the case, then it means that the other diagonal is BD. The diagonals of a rhombus are perpendicular. And so this means that the product of the slope of BD and the slope of AC is equal to -1. In the previous question, we found the slope of AC as -2. When we substitute that into our equation, we get the slope of BD as half. So now we have y is equal to half x plus c. To find c, we need to know one set of coordinates on the line BD. So let's go back to our diagram. The two diagonals AC and BD have a common midpoint, which we have labeled as Z. The x coordinate of this midpoint is -3 plus 4 divided by 2, which is half, and the y coordinate of the midpoint is 10 plus -4 divided by 2, which gives us 3. When we substitute these coordinates into our equation, we have 3 is equal to half times half plus c. When we make c the subject, we get 11 over 4. Hence, y is equal to half x plus 11 over 4. A curve has the equation y is equal to x cubed plus 8x squared plus 5x. Work out the coordinates of the two turning points. At a turning point or a stationary point, dy dx is equal to 0. So first off, we need to find dy dx. dy dx is equal to 3x squared plus 16x plus 5. And so we have to equate this to 0. And this gives us 3x squared plus 16x plus 5 equals 0. We can solve this quadratic equation by factorization. 16x can be rewritten as x plus 15x. When we factor out x for the first two terms, we are left with 3x plus 1. And when we factor out 5 for the final two terms, we have 3x plus 1. This can be rewritten as 3x plus 1 times x plus 5 is equal to 0. When 3x plus 1 is equal to 0, we have x equals negative 1 over 3. And when x plus 5 is equal to 0, we have x is equal to negative 5. So now we have the x coordinates of the two turning points. To find the corresponding y coordinates, we need to substitute these values into the equation of the curve. And so when x is equal to negative 1 over 3, we have y is equal to negative 1 over 3 cubed plus 8 times negative 1 over 3 squared plus 5 times negative 1 over 3. This gives us y equals negative 22 over 7. So for the first set of coordinates, we have negative 1 over 3, negative 22 over 7. When x is equal to negative 5, we have y is equal to negative 5 cubed plus 8 times negative 5 squared plus 5 times negative 5. This gives us y is equal to 50. So the second set of coordinates are negative 5, 50. Determine whether each of the turning points is a maximum or a minimum. To be able to determine this, we first need to find the second derivative of the curve. And we can do that by differentiating dy dx. dy dx is 3x squared plus 16x plus 5. When we differentiate this again, we have 6x plus 16. With the first stationary point, the x coordinate is negative 1 over 3. And so when we put that into the second derivative, we get a positive value. And so since this value is positive, it means that this turning point is a minimum. At the other stationary point where x is equal to negative 5, we have 6 times negative 5 plus 16. This gives us a negative value. And so since this value is negative, it means that this stationary point is a maximum. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.